Hello class, we're about to start section 401, properties of exponents. Now, what you're going to notice is that I have some pre-filled out pages here. This is because when I tried to write this out for the video, the writing was shifting. So what I did was I copied this here so that you all will be able to see the different examples and also their answers. So first, we have the definitions. It says when working with b to the n, b is called the base and n is called the exponent, or some people call it the power. Okay, now we have our first example. We have a to the fourth times a to the second. And then the simplification process is we will write down the first a 4 times. And then the a to the second, we'll write it out twice. And we know this is all multiplication. So when we count this up, we have a total of 1, 2, 3, 4, 5, 6. We have 6 a's, so our answer would be a to the 6th power. Now, with the rule in words, we're going to multiply, we add the powers. Now, when we multiply, and then we also must put down same base. When we multiply with the same base, you add the power. So to multiply with the same base, you add the powers. So here we have base of m times the base of n. We will carry over the base and add the exponents. Now we go down here to the second rule. We add x to the fifth divided by x to the second. We would expand this out. We would have 5 x's in our numerator and 2 x's in our denominator. Those x's would simplify out to 1, and we would just be left with x to the third power. To divide, and again, this is with the same base. Again, to divide with the same base, you subtract the powers. So we have our example here. We have b to the m over b to the n. We carry over our base, and we take the top exponent minus the bottom exponent, or the numerator's exponent minus the denominator's exponent. So we have m minus n. Now we have xy in parentheses to the 4th power. So we will write that out. We have xy, 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 and xy. And then when we multiply these together, we will have 4 x's, which gives us x to the 4th. And we will have 4 y's, which gives us y to the 4th. So our final answer would be x to the 4th, y to the 4th. Now it says apply the exponent to all factors. Now that's when you don't see an exponent showing here. So it'll be bc in parentheses to the n. So it would be b to the n, c to the n. Now we have r over s in parentheses to the 3rd power. So that means that this whole fraction is taken to the 3rd power. So we have r over s times r over s times r over s. And then we will multiply straight across, and we will have we have 3 r's, which is r to the 3rd, 3 s's, which is s to the 3rd. And then we want to apply the exponent to both the top and bottom. Now if you notice here, and I want to go back here, if you notice, no exponent is shown in here, no exponent is shown in here. That's how we apply it when there is no exponent shown here. Now it says apply the exponent to both top and bottom, and we have an example here, b over c. This would be b to the n over c to the n. Now we come here. We have y to the 4th to the 3rd. Now unlike this here, you notice inside this parenthesis here, we have an exponent with our variable. So this is what happens. It'll be y to the 4th, y to the 4th, y to the 4th. Now, we know that this would be 4 y's, 4 y's, and 4 y's, which would give us y to the 12th. Now, when you do a power to a power, you multiply the exponents. So you will multiply this 4 times 3, and that would have gave you y to the 12th, which is shown here, b to the m to the n, which will give you b to the m times n. Now, with these problems here, just to keep this mathematically correct, remember when you don't see an exponent, that exponent is assumed to be 1. So this is really x to the 1st and y to the 1st. And we know 1 times 4 is 4. And 1 times 4 is 4. That's how we get x to the 4th, y to the 4th. And the same for this fraction here. Now it says, note, all of the exponent rules apply only to multiplication and division. We have no rules for adding and subtracting yet. So remember that it only applies to multiplication and division, not the addition and subtraction. Now example 1. It says, simplify the following. Remove parentheses and combine factors that have the same base. Okay, now, if you notice, both of these have the same base. So, we would carry over the base, and then we could just add the exponents, because we know when we multiply, we would add the exponents. So that would be 3 plus 5, and we know that would give us 4 to the 8th power. Now, we can take our calculator and figure out what 4 to the 8th power is. And this would equal to 65,536. And that will be your final answer here. Now, we have negative 3f to the 4th times the parentheses 7f to the 2nd, g to the 7 to the 3rd. Now, the first thing we have to do is take care of what's inside of this parenthesis as far as with this exponent. So this would become 7 to the 3rd. This would be f to the 6th, and this would be g to the 21st. Because remember, when we take a power to a power, we multiply. And remember, this 7 is assumed to be to the 1st power, so that's 1 times 3, which gives us 3. Now, what we need to do next is this. We need to take the 7 to the 3rd power, for some reason, this keeps jumping here. And 7 to the 3rd is 343. And we have f to the 6th, g to the 21st. So we have negative 3 times 343. We know that that is going to give us a negative. That'll be a negative 1,029. And then we have f to the 4th times f to the 6th, which will give us f to the 10th. Because we know when we have the same base, we will add the exponents, and we only have just the g to the 21st. And this will be our final answer. Now, we scroll on to example 2. It says, simplify the following. Remove parentheses and combine factors that have the same base. Okay, so now we have these fractions. Now, the first thing we should do before we do any exponents is see if we can simplify this fraction. We actually can. Now, 6 and 8 both has 2 in common, so this will give us 3 and 4. Now, we look at these exponents. We have a to the 5th over a to the 2nd, so we can write that here, a to the 5 minus 2, because when they have the same base, we can subtract the exponents. And then we have b to the 3rd, which has doesn't have the same base in the denominator, and we have c to the 5th, and then our exponent is 2. So now we still will have 3 over 4. Now a to the 5 minus 2 is a to the 3rd. Then we have b to the 3rd all over c to the 5th. And that's squared. So now we square everything inside this parenthesis. 3 to the 2nd power we know is 9. 4 to the 2nd power we know is 16. A to the 3rd to the 2nd, we multiply the exponents, and that will give us a to the 6th. B to the 3rd to the 2nd will give us b to the 6th. And then finally, c to the 5th to the 2nd will give us c to the 10th. And this is the final answer. Okay, now we go here. Now we have x to the 3rd, y in parentheses to the 3rd power. Then we have x to the 4th, y to the 5th, all over x, y to the 2nd. So first, let's take care of this first parenthesis. Everything in here is taken to the 3rd power. So we will end up with x to the 9th, y to the 3rd. And we have x to the 4th, y to the 5th, all over xy squared. Now, x to the 9th times x to the 4th would give us x to the 13th. Y to the 3rd times y to the 5th is y to the 8th. Same base, you add the exponents, and we will have xy squared. Now, we have the same basis, so we subtract the exponents. So you have x to the 13th, and the exponent of this x is 1, so it'll be minus 1. And then you will have y to the 8th, and this exponent denominator is 2, so it's minus 2. And our final answer would be x to the 12th and y to the 6th. And that is the final answer for that problem. Now we scroll down here for the rule for zero exponents. Use the pattern from the table to find the rule. We have 2 to the 4th is 16, 2 to the 3rd is 8, 2 to the 2nd is 4, 2 to the 1st is 2, and 2 to the 0 is 1. And the same thing we did here with the 3's, all leading to 1. All what happens is we keep going one integer down from the higher integer. So if you notice, if you keep dividing everything by 3, when you get to 3 to the 0, it's 1. So anything except 0 to the 0 power equals 1. So we should put here b is not equal to 0. Okay, now I had to redraw this because, like I said before, some things were shifting. So I had to redraw this in order for it to show up correctly as far as me doing this, these examples for you. So we have everything in this parenthesis here taken to the 0 power. This does not equal 0, so this value to the 0 power is equal to 1. Now we go here to b. Now if you notice, this 0 power is only connected to the x. It's not connected to the 5. So this is equal to 5 times 1 because x to the 0 power is 1. So 5 times 1 will give you 5. Now we have negative 8 to the 0 power. Now all of this inside this parenthesis is taken to the 0 power. This does not equal 0, so your final answer here would be 1. Now we have D. We have negative 8 to the 0 power. Now when you look at this problem here, the only thing taken to the 0 power is the 8, not the negative sign. So we will bring the negative sign down, and 8 to the 0 power is 1. So that is your final answer. Now we come to the rules for negative exponents. We have our examples here, a squared over a to the 5th, and we also have 1 over a to the negative 4. Now a squared we know is the same as a times a, and a to the 5th we know is equivalent to 5a's. We simplify out these a's and we're left with 1 over a to the 3rd power. Now we can do the rule that we learned about dividing with the same base. You would subtract the bases, you would take the top base, the top exponent, minus the bottom exponent. So 2 minus 5 is a is negative 3. However, we cannot leave this as a negative. So what will happen is when you have any base, you will put 1 over, you would keep that base, and the exponent will become positive. So that's how we get 1 over a. And we have it here, b to the negative 1, you will put 1 over the base, and that exponent will become positive now. Now, we want to do this with the fraction to show you a different way of doing this. Okay, now we have 1 over, now you just learned this from here, this a to the negative 4 will become 1 over a to the 4th power. So we would change this to a regular division problem. It'll be 1 divided by 1 over a to the 4th. We'll change division to multiplication and take the reciprocal. And 1 times a to the 4th over 1 is a to the 4th over 1, or just a to the 4th. So your final answer should be a to the 4th. Now if we subtracted the exponents, we could change this 1 to a to the 0, and then we would subtract. We have a to the 0 minus a negative 4, which would give us